Got another motorboat rental on Trinity Lake in California problem. Let's go forward. So this is that same problem we had before in the sense that the marginal private value and marginal social value functions are given by P equals 300 minus 2Q. The marginal private cost curve, the private supply curve, is 60 plus Q again. And then I've got an externality, a negative externality. Marginal external cost is $30 per daily boat rental. And then what I'm looking for now, instead of the difference between the private market and socially best outcomes, I'm looking for the deadweight loss. And the easiest way to do this is going to be to graph this problem. Remember, we had the information from our previous application exercise, and I'm just going to bring that in. I guess I should add that if, well, not if, I'd like you to pause this screencast right now and try to work this problem out for yourself, hopefully in a group. Really struggle with it to the point where you think you've either hit the end of your rope or you've got a good answer, and only then look at the answer key. So pause this screencast. I'll give you a few seconds to do that. All right, welcome back. I know you've been furiously working on this problem. Well, let's work it together now. So here we have the information from the previous application exercise, and we have the relationship that the marginal private value function, which is equal to the marginal social value function, since there are no positive externalities, that's 300 minus 2Q, or P equals 300 minus 2Q. The marginal private cost function, that's our supply function, 60 plus Q. And the marginal social cost function, remember there was a marginal external cost constant at 30, so the marginal social cost function is just everywhere 30 bigger than the marginal private cost, that's 90 plus Q. So to find the deadweight loss, we're going to graph this. That's the way to do it. And I've handily pre-made my axes. On the x-axis is rentals per day, quantity. Price is going to be dollars per rental. I'm going to start it up here and try to write small. Let's start mapping stuff. All right, well, the marginal social value function, downward sloping, y-intercept of 300, slope of 2. So it's going to have a x-axis intercept of 150 and a y-axis intercept of 300. That's right there. All righty, then we have a bit flatter supply curve, about 1/5 of the way. Try to draw it roughly to scale. Don't know that I achieved that. Y-intercept of 60, a slope of positive 1, which is going to be flatter than our demand curve. I think I might have drawn it too flat. Doesn't really matter. We're going to do it algebraically. And that's the private market supply curve. Remember, that's the marginal private cost function. And we know from our algebra that resulted in the quantity 80 rentals per day. And it does look like I've sort of drawn this supply curve too flat because, 80 is just a little more than 1/2 of 150, and yet it looks like it's more like 2/3. Anyway, it doesn't matter. We have the algebra from the previous exercise. So the margin, let me even change colors here. Let's make it red. All that pollution makes us see red, we'll suggest. All right, the marginal social cost, I by the way, used to sail my sailboat on Trinity Lake, and the motorboats were just constantly noisy and making chop that, anyway, they were not a compatible use in my view. Anyways, so we know that the social optimum occurs at 70, and what we're going for here is what's the deadweight loss. And remember that the deadweight loss occurred because every motorboat rental past 70 imposed costs on society in excess of their benefit to anyone in society. If we count up the excess, that's supposed to be a straight up line from over 80, the excess of costs over benefits for all that excessive, those 10 rentals a day in excess of the socially best outcome, we would have our deadweight loss. And notice what we've got. We've got a triangle. If we flip it over, we've got a triangle with a height of 10, right? That's a height of 10 is that distance there. And we know that this distance here, any vertical distance between the marginal social cost curve is going to be equal to 30. That's the marginal external cost is the vertical distance between any 2 points at the same quantity at 80. It's going to be the marginal social cost is 30 higher than the marginal private cost at every quantity, including 80. So we've got a deadweight loss. Remember the area of a triangle. Deadweight loss is 1/2 times our base, which we're going to rotate it on its bottom, and our base is going to be 30. And we're going to multiply that by our height, which is 10, and we get 300 over 2, otherwise known as 150. And the units of deadweight loss are dollars per day. The y-axis units are dollars per rental. The x-axis units are rentals per day. When we multiply price and quantity together, the rentals cancel out, and we're left with dollars per day. So there's our answer, 150 a day. Oh, I've got this, I injected an extra page by mistake, so I got a blank page, but then I've got the pretty graph that I just drew sort of by hand, by stylus, which is even messier than by when I draw things by pencil. Oh no, I used that extra page. Here we are. This is the same graph I just had, only it's drawn to scale. And so you can contemplate that graph. You don't need my voiceover to do it.